All right, so in this week we move into logarithmic integration. So you've already done some of this in methods, and there's not that much of a big difference in specialist, except that we now put absolute value signs around our function that's part of ln. So that's really the only difference, and that the complexity of the functions we integrate might be a little bit more. So we'll talk about why we put absolute value signs out the front, but let's get into it. All right, so what we're going to do is integrate this 14 over 2x take 1. So to do that, what I'm going to do, I'm just going to rewrite the question. I'm going to obviously leave the 2x take 1 is where it is, and I'm going to put the derivative on the top. Remember to see that ln type integral, what we need to do is have our derivative on top of our function, right? And then that becomes ln of f of x plus c. So that's what I've got here, right? I've got the derivative of the function on the bottom of the fraction in the numerator position. Now what I need to do to be able to make sure that this is still equal to this is put a 7 out the front. So if I multiply the 7 through, I've got 7 times 2, which is 14 over 2x take 1 dx. From there, I can leave the 7 out the front and just integrate this. So that gives me ln of 2x take 1 plus c. Okay? Now, the reason why we put absolute value signs out the front not out the front, but around our part for ln, you'll know from methods that if we have the natural log of a negative number, it doesn't exist. So we're putting absolute value signs there to basically get around that idea of, well, if we input a value for x and 2x, this function 2x take 1 makes it into a negative number, then the ln can still handle it because it will be the absolute value of that negative number. So that's really the reason why. And that is the only difference between methods in specialist in the syllabus as well. All right, so let's go to integrating this. So I'm going to rewrite that derivative, the x squared plus 1 with 2x over the top because that's the derivative of x squared plus 1. And then what I'm going to do, put out the front, is a 3 because 3 times 2x gives me 6. From there, I leave the 3 where it is, integrate this, which gives me ln of x squared plus 1 with absolute value signs plus c. Okay, so really just get used to putting those absolute value signs in there, and I guess just extending on your methods knowledge.